Determine the greatest height reached by the...
Okay, so for this question, you're given the equation. The equation represents the path of a rocket. That's represented by a parabola. What does h represent? The height of the rocket in what? Meters. And t represents the time elapsed in seconds, okay? So they tell us in the question that the rocket is being launched off a building. So I want you to visualize this. Pretend this is the building. There's a rocket that's going, I don't know how to draw this, off the building. And where's it going to go? Up into the air and never come down, or is it going to go off the building and come hit the ground? So even just by looking at the equation, the a value is negative, so you know that the parabola is going to open how? Down. So it's going to look something like this, right? It's going to be shot off the building and come to the ground. Okay? So if we do end up graphing it after, it's going to look something like this, where x is the ground, right? Or sorry, this x-axis is the ground, and it shows us the time in seconds, and the y-axis is the height of the rocket, and it tells us how high off the ground it is. So before you even graph this, look at the equation. Which term represents the y-intercept? Which term? A, B, or C? Okay, so you know that the y-intercept is what? Which, does that make sense? Where does the rocket start? Does it start on the ground, or does it start on a building? So how high is the building? 5 meters from the ground. So right away you know that information, okay? So we have to figure out the greatest height of the rocket, because like I said, it's going to be modeled by a parabola. It's going to go up, and then it's eventually going to come down. So a parabola is symmetrical. When you graph it, this part will be shown, but it doesn't matter in the context of this question, because we don't go back in time. We're only looking at this part of the parabola. Hold on, this part here. That's the only part of the parabola we're focusing on. Okay, does that make sense? So we're trying to find the greatest height of the rocket. Where is that point located? It will be located at the vertex, somewhere around here. Good. And we know that it has a maximum value, right? Okay, so it has a maximum value, and again, the direction of opening tells us that. Think about it. The rocket can't go higher than this point. So we're going to figure out the maximum y value, right? Okay, so how are we going to do this? Okay, what is the relationship that we're looking at here? We're looking at time is all your independent variable, your x variable always is on the left column of a table, and height. So we already know that at 0 seconds, when no time has started yet, where does the rocket start? 5. Okay, so let's fill in this table right now. Let's go up to 8. So we filled in the table, okay, and we've confirmed that the height of the, so what's the height of the building? That's one of the questions that they asked you. What is the height of the building? We already answered that?
0.5.
Okay, so the building is how high? 5 meters high. So you can answer that question for C. Okay, how do you know that? Because when the time is 0, when we haven't even launched the rocket, the height is 5 meters, so we know that's where it's going to start. Just by looking at your table, roughly, now I showed you on Desmos, we looked it up on Desmos, but when would how can you look at the table to figure out when the rocket would hit the ground? It would be between how many seconds?
7.
Right, it's somewhere between 7 and 8 seconds, because we know that eventually the height would be equal to 0 somewhere in between here, okay? So we know the exact answer because we went on Desmos. Okay, so we have to find the vertex. Remember what we learned on Friday? We know that there is something that goes through the vertex. What is that? What goes through the vertex? Axis of symmetry goes through the vertex, right? And to find the axis of symmetry, well, we don't know the other x-intercept, but we know that the axis of symmetry is when what? When the y coordinates have the same value. Think about it. Let's say I pick this point and this point. halfway between these 2 points is the midpoint, which is the axis of symmetry. So you're going to look at your table, and we're going to find out, we're going to pick 2 points that have the same y value, because that means they're going to be at the same height, right? So which 2 points do you want to pick that have the same y value? You want to pick this one? 135, you said, and 635. Okay, does everyone agree that halfway between those 2 coordinates will be the axis of symmetry? So we need to find the midpoint of our x coordinate, right? So we're going to add, 1 plus 6. We don't care about the y value of the coordinate. We only care about the x's, because the axis of symmetry is x equals, right? We want to know the x coordinate, because that's the x coordinate of the vertex. So we're going to add 1 plus what? 6 divided by 2. What's 1 plus 6? 7 divided by 2 equals 3.5. So we know that the axis of symmetry is x equals 3.5. And we could have used another coordinate. Just let's do this in our head right now. 255 and 555. Those have the same y coordinate. What's 2 plus 5? 7 divided by 2? 3.5. Okay, does that make sense?
Yes.
So we know the x value of the vertex is, so the vertex is located at 3.5 and something. We're trying to figure out the maximum height of the rocket. How high did the rocket go? We're trying to figure out the y value of the vertex. Well, if you know the x value of the vertex, can you use that information and figure out y?
Yeah.
How?
Plug it into
The equation, right? The axis of symmetry is x equals 3.5. So when 3.5 seconds has passed, we're going to figure out the max height, right? At that time, x equals 3.5, that will give us the highest point because it's located at the vertex. So all we have to do is plug it in for t. Our x variable represented time, and we're going to find the height. So we're just going to plug it in. -5, t is 3.5 squared plus 35 times 3.5 plus 5, and make sure you're doing this first. 3.5 times 3.5, then you multiply it by -5. Okay, so if we simplify this, we get -5 times 12.25 plus 122.5 plus 5 equals 66.25. So the maximum height that the rocket will reach is 66.25 meters, because as we saw before, let's say the parabola looks something like this. So it starts at 0.5, and the highest point it goes is at 3.5, 66.25. That's the maximum height, which means that it takes 3.5 seconds to reach a height of 66.25. The vertex gives you a lot of information. It starts at 5 meters above the ground, and how long is the rocket in flight? How many seconds does it take for it to hit the ground? When I showed you on Desmos, does anyone remember the number? 7. It was 7.14 seconds, so you can answer that for question B.
And then how